All right, so we're going to do some investigation here. This time we have a polynomial on top. And I'm looking at that polynomial on top and I'm thinking, you know what? That can be factored. So let's take a look what happens when we factor. It's going to factor to x plus 3 times x plus 2. Oh, and that makes me happy because I have an x plus 3 on the bottom as well. And you know that you can cancel common factors. So I'm going to cancel these two out. So really, this is the function y equals x plus 2. But hold on though, because it's still a rational function. And I still got to pay attention to the domain here. So remember, the domain of the function is all x's except for -3. So what's this graph going to look like? This graph is going to be the graph of y equals x plus 2, but it has what I like to call a hole at x equals -3. That's what's going on. The graph is still or the function is still undefined at x equals -3. But the rest of the graph behaves like y equals x plus 2. So remember, the graph of y equals x plus 2 has a slope of 1 and a y-intercept of 2. It also has an x-intercept of -2. So it's going to look something like this. But I'm going to fix it in a second because I know that it's undefined at -3. So what I'm going to do here is I'm going to put a little hole in my graph. And that's what that graph looks like. It's the line y equals x plus 2, but at x equals -3, it's undefined. Pretty neat. And that gets me thinking about this one. I wonder if I can factor the numerator again. Let's see what's happening. Looks like it's going to factor to x plus 4 times x minus 1. Okay. Well, nothing cancels here. That's all right. But what I do know from this is that my x-intercepts are going to be at x equals -4 and at x equals +1, because that's the values that make my numerator 0. Those are my x-intercepts. And while I'm at it, the y-intercept is going to be y equals -4 over -2, or y equals 2. So I get some points like -4, 0. I get 1, 0. And I'm also going to get 0, 2. Those are some intercepts. My vertical asymptote, that stays the same. That's going to be x equals 2. Remember, the horizontal asymptote is the limit as x approaches infinity. Now, the greater power is on top. So that means this limit goes off to infinity. All the other ones went off to a number, like a horizontal value. So this has no horizontal asymptote. If I write the word none. There is no horizontal asymptote. So what's going on then as x gets larger and larger and larger? Well, to do that, let's do some division. Let's divide x minus 2 into x squared plus 3x minus 4. So you might remember doing our division, x squared plus 3x minus 4. Let's see, it's going to go in x times, so x times x is x squared. I get a minus 2x. Remember, when I subtract that, I get a 5x, bring down my minus 4. That's going to go in positive 5 times, so I get 5x minus 10. When I do my subtraction, I'm going to get a positive 6 as my answer. So really, when we go off to infinity, the limit as x approaches infinity of our function, it becomes x plus 5, and there's a remainder of 6. So what this is telling me then is as x gets really, really, really large, and also very small, we can do the same thing for negative infinity, this graph becomes or looks a lot like the line y equals x plus 5. So we're going to call this a slant asymptote. And the slant asymptote occurred because there was no horizontal asymptote. If the limit goes off to infinity, let's check for a slant asymptote. And that slant asymptote is going to be the equation y equals x plus 5. I'll show you what that looks like in a minute. Let's finish this up now by doing a sign analysis. So we're going to take a look at some of our x values. We have an x value at -4. We have an x value at +1. And we also have an x value at +2 to see what's going on. And I'm going to do this sign analysis by thinking about my function. I know the numerator is a parabola. And I know it's a parabola that looks something like this. It crosses at -4 and +1. So when I go to the left of -4, when x is less than -4, my numerator is positive because my parabola is above the x-axis. When I go less than -4, my x value is negative though. So to the left of -4, my function's value is negative. If we go between -4 and 1, I'm going to look at my parabola. Between -4 and 1, my parabola is negative, so my numerator is negative. Also, my x value is going to, or my denominator is going to be negative, so a negative divided by a negative is a positive. If I go between 1 and 2, I know that my numerator becomes positive because the parabola is above the x-axis there, but my denominator is still negative. And when I go outside of 2 and I go greater than 2, I get a positive over a positive. So my function is positive. All right, so let's take a look at this graph. This is going to be an interesting graph to do. So first of all, I got a vertical asymptote at x equals 2. You know what I know what this graph is going to look like, so I'm going to actually move it down a little bit more. All right, so I got a vertical asymptote at x equals 2. I've got a slant asymptote at the line y equals x plus 5. Okay, so like I did before, that's going to be a line with a slope of 1 that has a y-intercept of 5. It also crosses the x-axis at -5. It's going to look like this. I'm going to extend my vertical asymptote a little bit as well. I also have an x-intercept at -4, and I have an x-intercept at -1, and I have a y-intercept, a +1, and I have a y-intercept at +2. So let's take a look at our signs now. My graph goes negative up until -4 and then becomes positive. So it's coming like this. It's positive now. It goes through my y-axis. And then it's still positive, but once it hits 1, it becomes negative. So it's going down that way. And now, once I go beyond 2, my graph is positive. But it has to follow this vertical asymptote for a little bit. And then it's going to bend and follow the slant asymptote. What a wild looking graph that is. Holy cow. So it kind of looks like our typical graph that might look like that. But it's kind of like rotated a little bit. Oh, my picture's horrible there. Let's not pay attention to that picture. Yikes. But that slant asymptote is pretty neat. And again, that slant asymptote occurs when the limit of the function goes off to infinity. So let's take a look at maybe one more. Do you want to try this one on your own? Give it a shot. All right. So let's see. First of all, I do my vertical asymptote, and that's going to be at x equals -3. My horizontal asymptote, if I take my limit as x approaches infinity, the larger power is on the numerator, so there is no horizontal asymptote, which means there's going to be a slant asymptote. We can do our division. Do you remember synthetic division? Why don't we do some synthetic division here? I'm going to divide -3. My coefficients are 1, 2, and -8. Bring down my 1. -3 times 1 is -3. Combining that gives me a negative 1. Negative 3 times negative 1 is positive 3. That gives me a negative 5. So if I think about this in terms of my equation, I'm going to have y equals 1x minus 1 minus 5 over x plus 3. So my slant asymptote, I need a little bit of room to write that slant asymptote. The slant asymptote is really y equals x minus 1. Pretty cool. Okay, our x-intercept, let's factor the numerator. The numerator is going to factor to x plus 4 times x minus 2. Nothing's canceling here. So my x-intercepts then are at x equals negative 4 and x equals positive 2. They're at negative 4, 0, and 2, 0. The y-intercept is where x equals 0. So that's going to be at y equals negative 8 over 3. So 0, negative 8 thirds. Let's see what the signs are doing. Let's go up here for a sign analysis. I got to put in my values. I got a value of negative 4. That's a 0. I got a vertical asymptote at negative 3. And I got another 0 at x equals 2. So I got to check my signs around here. So if I go to the left of negative 4, and I like that parabola idea. Okay, so my parabola in my numerator, I know has zeros at negative 4 and positive 2. So to the left of negative 4, my numerator is positive. My denominator is negative. So I'm negative down there. Between negative 4 and negative 3, my numerator now, my parabola is below the x-axis. That's negative. And if I plug in a number less than negative 3, I'm still negative. But a negative divided by a negative is positive. Between negative 3 and 2, how about when x is 0? How about our y-intercept? Our y-intercept is negative 8 thirds. It's negative there. When we go beyond x equals 2, our numerator, our parabola is positive. Our line is positive. So once you go past 2, our function is positive. Let's see what this looks like. So I got to go all the way out to negative 4. I got to go out to positive 2. I've got a slant asymptote at y equals x minus 1. So y equals x minus 1 is going to have a y-intercept at negative 1. Let's see. I'm going to graph my vertical asymptote. It's at negative 3. My x-intercept is at negative 4 and at positive 2. And my slant asymptote is y equals x minus 1. That's going to have a y-intercept at negative 1. It's also going to go through 0, 1. The slant asymptote is going to look like that. I have a y-intercept at negative 8 thirds. That's a little bit more than negative 2. All right, let's see what this graph is doing. So to the left of negative 4, I'm negative, so I'm following the slant asymptote. And then I got to turn up. And then I got to head up towards my vertical asymptote. Now, once I'm to the right of negative 3, but not yet at negative 2, my graph is negative, and I see my y-intercept, I see my x-intercept, and then I follow that asymptote going out as well. Pretty interesting looking graph there. Like I said, fun with graphing. Let's go.